In this example, we want to verify the identity that says 1 plus cosine 2x divided by sine 2x is equal to cotangent of x. Well, when I look at this, the left-hand side looks a whole lot more complicated than the right-hand side. So I'm going to start this identity by working with the left-hand side. So I'm going to start with this. And the first thing that seems clear to me is that I need to use my double angle formulas. So in the denominator, I've got sine of 2x. So that's 2 sine of x cosine of x. Now, in the numerator, I've got 1 plus cosine 2x. And when I look at cosine 2x, I've got a lot of options on what I can do to simplify that with. But one of the first things I'm going to do is I am going to just make a guess as to which of my double angle formulas I'm going to use for cosine 2x. So I'm going to start by using the formula that uses cosine. So I'm going to write this as 1 plus 2 cosine squared x minus 1. So when I look at this, my 1's cancel out. So I've got 2 cosine squared x over 2 sine x cosine x. So when I look at this, the 2's will cancel. I have cosine squared x, so I can think of that as cosine x times cosine x over sine of x cosine x. The cosine x's cancel, and I'm left with cosine of x over sine of x, which is exactly cotangent of x. So it looks like I made a good guess with which formula to use for my cosine of 2x, but it probably could have worked out if I had used the other ones. Now, let's look at one more identity before we move on to the next section. In this identity, let's look at cotangent of A minus tangent of A divided by cotangent of A plus tangent of A. And I want to show, believe it or not, that that's another formula that's equivalent to cosine of 2a. Now, again here, when I look at this, I can start with either side that I want. It's tempting to look at, well, I'm just talking about formulas for cosine of 2a, let's use that. But my instinct here is to go back and do some of what we did in that first section and rewrite all of this in terms of sines and cosines. If I do that, I'm not going to rewrite the left-hand side, but I will simplify it. Cotangent of A is cosine of A over sine of A. Cosine of A over sine of A. Minus tangent of A is sine of A over cosine of A. And that's all over the same two terms, but instead of subtracting them, we're now going to add them. Now, this is an example of a complex fraction, and one of the first things I'm going to do to simplify a complex fraction is multiply by the least common denominator of all of the fractions in this problem. And I'm going to do that in the numerator and the denominator. So, in effect, what I'm multiplying by is 1. So when I multiply cosine of A over sine of A times sine of A cosine of A, the sine of A's cancel, and I get cosine squared of A. Minus, I'm going to do the same thing to this term. The cosine of A's cancel, and I get sine squared of A. Since my denominator was the same two terms, but added instead of subtracted, I'm going to get the same two terms, but added instead of subtracted. And hopefully that looks familiar to us. Cosine squared A plus sine squared A is 1. So this gives me cosine squared A minus sine squared A, which we recognize as one of our other formulas for cosine of 2A. So when we simplify this, we're going to get cosine of 2A. Now, I have some other problems for you to practice on. As a reminder, this is section 5.5, and the problems I want you to look at are 11, 13, 17, 21, 23, 25, 27, 29, and 31.